Children, measurement is the basis for all important scientific study. And also, without measurement, we can't lead our life. In our daily life, measurement plays an important role, is it not? You imagine that you are going to a shop, and how will you get a sugar, a particular quantity? You have to mention how much you are going to get, is it not? So, 1 kilogram, like that we are using the measurement in our daily life. If you are going to a shop, want to get a cloth, then how will you give the measurement? Then 1 meter, 2 meter of cloth, is it not? So measurement is very important in our daily life. You have to gain knowledge regarding this measurement. Then come to the case of physical quantities and units. What are physical quantities? We are having many measuring instruments. With the help of that instrument, we can easily measure that particular quantity. So these are that particular object. So these are called as the physical quantities. I will repeat once again. Physical quantity is a quantity that can be measured using some physical instruments. Okay. Physical quantities also divided into two categories. Physical quantities. Physical quantity is a quantity that can be measured. Okay. Then physical quantities are of two types. One is the fundamental quantity and the other one is derived quantity. In the lower classes, we have studied about length, mass, time and temperature, etc. These are called the fundamental quantities. Suppose if I give an example, velocity. Velocity is defined as the distance traveled by time taken. So here we are having two types of quantities involved here. One is the distance. Distance usually measured in meter and time usually measured in seconds. Is it not? Distance traveled and time taken. This is the basic one. And this physical quantities have a numerical value and a unit of measurement. Okay. Then here you can connect these two things. 3 kilograms, is it not? And 3 is the numerical value and kilogram is that particular quantity related to that object. Suppose if you are buying vegetable, then you are buying the vegetable in kilogram, then it is denoted as kilograms, is it not? So you have to combine these two things. When you denote physical quantities, you have to use a numerical value and that of the unit. Okay. Then coming to the case of units. What is a unit? A unit is a standard quantity with which the unknown quantities are compared. You are having 5 to 7 number of mangoes. Okay. You don't know the weight of that mango. When you compare with that of another measuring tool, then only you can find the what is the quantity that is to be weighed, is it not? So we have to compare with that of the another standard one, and for this we are using some weights in our daily life, is it not? This is the balance, and using this balance you are weighing and measuring the mass of the object, is it not? Then next one is, these are all the basic standard weights, is it not? 1 kilogram, 100 gram, 200 grams, like that we are having a standard one. So if you want to buy sugar, then you have to compare with that of these physical measuring weights. So this is denoted here as it is compared with that of the standard quantities. See, a unit is a standard quantity with which the known quantities are compared. Okay. By comparing with that, you can get the what is the real value of that quantity. Then it is defined as the specific magnitude of physical quantity that has been adopted by law or convention. Here also you are having the same thing, that is 10 feet. Here is a numerical value and the quantity that is related to the measure of that particular quantity, that is feet. If you are measuring length, then it is in feet. Okay. So in this way we are measuring the units. Units is completely different from physical quantities. Okay. Physical quantities is divided into two types, and one is the fundamental, the other one is the derived quantity. You are familiar with these two things. Okay. Now coming to the case of the things. Previously what system we have used? CGS system, centimeter, gram and second. In FPS system, we have used foot, pound, second. In MKS, meter, kilogram, second. Okay. These are the standard unit systems of earlier times. Now we are using what system of units? This is the MKS system, that is meter, kilogram and second. Measuring length, you have to use meter. For measuring mass, you have to use kilogram, and for measuring time, you have to use second. Okay. Now, coming to the case of the SI system, that is SI means International System of Units. In the abbreviation book back question, you may be asked like this. SI give abbreviation as International System of Units. This is announced in 1960 for the international usage in the meeting held at Paris. Okay, that is the General Conference meeting. This is the General Conference on Weights and Measures. Now coming to the case of the SI System of Units. SI system, we know System International or International System of Units, in whatever the type you may call it as. Okay, System International or International System of Units. SI system of units is the modified and improved form of the previous system of units. Okay, it is accepted in almost all the countries. All over the world, we are using the SI system of units. If you are measuring 1 kilogram of sugar in India, then if you take that in to foreign countries, some other foreign countries, it is weighed as same 1 kilogram. Okay, that is the main usage of using the system international units. It won't change, it depends on the place of measuring that particular object. Okay. Then, what are derived units? The units to measure the fundamental quantities are called fundamental units. We know very well, is it not? And the units which are used to measure the derived quantities are called derived units. See here, length, mass, time, temperature, electric current, luminous intensity, amount of substance. These are all called as the basic fundamental quantities. Okay. Then unit for length is meter, mass kilogram, time second, temperature Kelvin, electric current ampere, luminous intensity candela, amount of substance mole. Okay, you have to differentiate the units and symbols. Suppose if you are doing some numerical problems, then you have to use those symbols. Is it not? You should not write it in full form. For that, you have to be familiar with the top symbols. M for mass, that is M for meter length. Mass, it is kilogram. You should use all small letters. Suppose if it is the name of the scientist, then you have to use only the first letter, that is as capital. For example, you take temperature. For temperature, we are using Kelvin. It is in small letter, but in symbol, you have to use only the capital letter. It is not differentiated in this case, but if you switch over to electric current, see here, it is ampere. Ampere is the name of the scientist, and you have to use capital A to denote the symbol related to electric current. Okay. Candela and CD, amount of the substance, it is mole. You have to use to differentiate MOLE with that of MOL. Okay. In symbol, you have to use only MOL. Keep in mind all those symbols for the relevant higher powers and lower powers. Okay. This is called as smaller units and larger units. For measuring small lengths, we are using the distance between the two atoms and the distance between the nucleus and that of a particular electron. In those cases, we are using the smaller units, is it not? And for measuring the larger distances, you take astronomical unit, that is sun and that of the earth. These are all the celestial bodies, and they are far away from Earth, is it not? So you have to measure the larger distances also in some times, and so you have to use the larger distances and also the smaller distances. You have to be very familiar with the smaller units and larger units. Okay, with this basic, let us enter into the fundamental units. What are the fundamental units? Length, mass and time. These three called as fundamental units. Okay. Some more fundamental units are there as we have seen. Is it not? As we have seen in the tabular column. See in this tabular column. These are also the fundamental units. 1, 2 quantities. Fundamental quantities. 1, 2, 3, 4, 5, 6, 7. Is it not? I'm taking now only three fundamental quantities. What are they? Length, mass and time. Now let us look into the Now let us come to the length. Length is the extent of something between the 2 points. Okay. SI system, SI unit of length is meter. SI unit of length is meter. Suppose if you want to define 1 meter, then how will you define? 1 meter is the distance travelled by the light. Light travels in 1 second 3 lakhs kilometer, is it not? So, here the light travelled, the distance travelled by the light through vacuum in 1 by part of, that is 29 crores 97 lakhs 92,458 seconds. If you divide the 1 by this number, that much small we are having the length, that is 1 meter. You are having 1 meter scale in your hand, is it not? Then see that that much smaller your scale when you compare that of the distance between the celestial bodies. You take 2 points and if you measure the distance between the 2 points, then it is called as length. Okay. Now, to measure the very large distances, what will you do? That is, the distances are known as astronomical units or astronomical objects. We are using the following units. Okay, first one is the astronomical unit and light year, parsec. These are all the basic three important large distance measuring units. Now let us see one by one what is astronomical unit, light year and parsec. Okay. Now look at the definition. It is the mean distance of the center of the sun from the center of the earth. I will give you one picture. See this picture. Where is the center of the sun? Here it is the center of the sun. And you look at the center of the earth. If you measure the distance between the sun and that of the earth, the center point, then that is called as astronomical unit. Then what is the value of astronomical unit? One astronomical unit is equal to 1.496 into 10 to the power of 11 meter. You have to memorize this particular unit. Okay. You have to memorize all those units which is given as here because you are going to substitute these values in the numerical problems given in the book, and also you are going to work out some other problems which is very challenging, and if you know the value then only you can substitute the values. 1.496 into 10 to the power of 11 meter, that is called astronomical unit. How will you define astronomical unit? It is the mean distance of the center of the sun from the center of the earth. Okay, and if you look at this picture it will be very familiar. Then you can easily understand what is astronomical unit. Okay. Now coming to the case of light year. It is the distance travelled by the light in 1 year in vacuum. Note the point, in 1 year in vacuum, and it is equal to 9.46 into 10 to the power of 15 meter. Okay. What is the value of light year? It is 9.46 into 10 to the power of 15 meter. Previously, we have studied about the astronomical unit, and what is the value of astronomical unit? One astronomical unit is equal to 1.496 into 10 to the power of 11 meter. Okay. Now, coming to the case of parsec. Parsec is the unit of distance. It is also a unit of distance, which is used to measure the astronomical objects which is outside the solar system. That much larger it is. When you compare, we are using inside the solar system, usually we are using the unit in light year. But if you multiply the light year, 3.26 light year, which is measured outside the solar system. Okay, in the solar system we are having how many planets? We are having 8 planets, is it not? With outside the solar system we are using the unit which is parsec. You have to remember this. 1 parsec is equal to 3.26 light year. Watch carefully the physical quantity and expression and unit related to derived quantities. See, area is length into breadth. This is particularly for the rectangle. You know, square. For square, you have to multiply the side by side, is it not? So, the unit is meter square. If you take volume, area into height, that is meter cube. You take density, mass per volume. These are the mass is the basic quantity, and volume is also another combination of the basic quantities, that is meter, is it not? Length, breadth and height. So mass by volume, kilogram per meter cube, or you can say this as kilogram meter power minus 3. Okay, there should not be any space between the two physical quantities. Okay, keep in mind. And then momentum, mass into velocity, kilogram meter per second. Kilogram meter per second. You know, velocity is meter per second, and mass kilogram meter per second. Okay, then acceleration is velocity by time, meter per second squared or meter second power minus 2. Force is ma, that is mass into acceleration, kilogram meter second power minus 2 or Newton. Usually force is the unit of force is Newton, and hence it is N. Additional unit is N, or else you can write it as kilogram meter second power minus 2. For pressure it is force per area, Newton meter power minus 2 or Newton per meter square. In generally, we are measuring pressure in Pascal, so it is PA. It is the name of the scientist, and hence you have to use small p and A. That is the unit of pressure. After that, it is energy. Energy is force into distance, that is Newton meter or joule. Energy is measured in joule. Work is also measured in joule. Okay, keep it in mind. Work and energy both are measured in joule. You have to write it as capital J or small JOULE. Okay, surface tension. Surface tension is the force exerted per unit length, is it not? Force per length. Force is Newton and length in meter. Okay, so it is Newton meter power minus 1. Keep it in mind. You have to memorize this table, and you have to know the units related to the physical quantity and the expression related to the physical quantity. Astronomical unit, light year and parsec, is it not? After that, coming to the important tabular column, it is larger unit in meter. You know kilometer, that is 10 to the power of 3 meter. Astronomical unit, just now we have studied 1.496 into 10 to the power of 11 meter, and light year 9.46 into 10 to the power of 15 meter, and parsec PC 3.08 into 10 to the power of 16 meter. Is it not? These are all the larger units. And coming to the case of important point, that is we are living in Milky Way galaxy. Is it not? So the nearest star, Alpha Centauri, is about 1.34 parsec from the sun. Parsec is the unit measured for the object which is outside the solar system. It is nearby. Alpha Centauri is the nearest star, and it is in 1.36 parsec from the sun. Okay, most of the stars visible to the unaided eye in the night sky. If you look at the night sky, you can see many stars, is it not? Because they are located in 500 parsec distance from the sun. To measure the small distance, we have to use the small units for meters. That is Fermi, it is 10 to the power of minus 15 meter. Armstrong, that is 10 to the power of minus 10 meter. Nanometer, it is 10 to the power of minus 9 meter. And micron, that is 10 to the power of minus 6 meter. 10 to the power of minus 6 meter. Okay, you should not confuse with the depth in micro and mega, is it not? Micrometer can also be called as mu-m, 10 to the power of minus 6 meter. Millimeter, it is mm, that is 10 to the power of minus 3 meter. And centimeter, it is cm, 10 to the power of minus 2 meter. Okay, these are all the smaller units. Look at the table and you have to be familiar with that of the powers. And sometimes the questions asked in powers may confuse you, so you have to be very familiar with that of the power of the units. Okay, now coming to the case of the mass. Mass is the quantity of matter contained in the body. How much matter in the body is measured using mass. Okay, you take 1 kilogram of mass here in the earth. If you take the same mass to the moon, then both having the same mass. But weight is different, is it not? Weight is differ from the planet to planet and planet to satellites and etc. Is it not? Weight is different from place to place, but mass never changes. So the mass is the quantity of matter contained in the body. 1 kilogram is the mass of a particular international prototype cylinder made of platinum iridium alloy. Here the standard comparing the material is platinum iridium alloy kept at International Bureau of Weights and Measures in France. Okay, then see, look at the tables, look at the following units. 1 gram is equal to 1 by 1000 in telegraph. 1 by 1000 into 1 kilogram, that is 0.001 kilogram. 1 milligram is, you have to divide it by 1 by 6 digits of 0. So the value will be 0.00001 kilogram. In the 6th digit you have to start the number, that is 1 here. The quintal is equal to 100 kilogram. And metric ton, 1 metric ton is equal to 1000 kilogram or 10 quintal. 1000 kilogram or 10 quintal. Okay, these are all the quantities related to mass. Before that, we have to know one important thing, that is atomic mass. Mass of the proton, neutron and electron can be determined using the atomic mass unit. Simply you can call it as AMU, which is defined in standard form as 1 by 12th of the mass of carbon 12 atoms. You take carbon 12 atoms and if you have this value, that is 1 by 12th of the mass of carbon 12 atom, then that will be equal to 1 atomic mass unit. This is simply denoted as AMU. You have to use only small letters AMU. Okay, mass of 1 milliliter of water is 1 gram and mass of 1 liter of water is 1 kilogram. Already we know about this important fact, is it not? Then coming to the case of the time. This is the duration between the two events. You take that one example, you are starting from your school and you are reaching your house. Then there will be two incidents, there are two events. And if you calculate the duration of this event, then that is the time. Okay, the SI unit of time is second. That is 1 second of the time is required to for the light to propagate 29 crores 97 lakhs 92,458 meters. Okay, already we have seen about this number, is it not? Then it is also defined as 1 by 86 or 400th part of mean solar day. Solar day, is it not? Mean solar day. The larger units for measuring time or day, month, year and millennium, etc. Then 1 millennium is equal to 3.16 into 10 to the power of 9 seconds. 1 millennium is, the value of 1 millennium is 3.16 into 10 to the power of 9 seconds. Okay, then next fundamental unit is the temperature. Temperature is the measure of the hotness or coldness of a body, which may be very cool or which may be very hot. If you measure the degree of hotness or coldness, then it is called as the temperature. The SI unit of temperature in Kelvin is, the SI unit of temperature is Kelvin, K. 1 Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of the water. You know what is triple point? I'll explain you what is triple point. At a particular temperature and pressure, a substance can exist in equilibrium in the liquid, solid and gaseous state. That is, the same substance exists in all the three forms. Liquid, solid and gaseous state. This is occurred only at particular temperature and pressure. And that particular temperature for water is 0.01 degrees Celsius. If you look at this 0.01 degrees Celsius, you can see water existing in all the three states, that is liquid, solid and gaseous state. This is occur only in vacuum, and that particular pressure is 611.5 Pascal. This is the triple point explained in your book. Okay children, tomorrow I will see you with a different topic, and that will be the continuation of this lesson. See you tomorrow. Thank you for watching.